What infrastructure challenges emerge when training models with hundreds of billions of parameters, and how is Kubernetes evolving to handle these massive workloads?
Yeah, the scaling demands just keep growing. We've certainly seen firsthand the challenges that result from running some of the world's largest foundational models on EKS. Some of these are unique to model training workload patterns, but it really comes down to just the nature of longer running distributed jobs and tuning the system to sustain performance as the workload reaches massive scale. And at AWS, one of the jobs of the EKS team here is making sure that we're bringing all the goodness of the AWS infrastructure innovation to Kubernetes customers. So support for multiple network cards and CNI plugins, support for Elastic Fabric adapter to do OS bypass networking between multiple nodes. We've worked deeply with NVIDIA EC2 on some of the newer instance types to make sure that those work in Kubernetes, because again, NVIDIA is releasing new instance types to handle larger scale. If they don't work with Kubernetes, people just aren't gonna use them. So yeah, from a Kubernetes side, the Kubernetes control plane is probably the first bottleneck that we see that you run into when you're running workloads at this scale. We actually just announced EKS a few weeks ago at the AWS New York Summit support for clusters of up to 100,000 nodes, which is an industry-leading scale. There was a lot of work behind the scenes that went into this. We released a deep dive technical blog that went into some of those details, including things like offloading the consensus layer of etcd to an internal service at Amazon that allows us to scale horizontally.